everybody, this is Sam. Let's look at test number one. We're gonna together solve the real sets. Look at problem number 15. This problem states that for what positive number is the square root of the number the same as the number divided by 40? For what positive number? To solve this kind of problems, let the positive number is x. Let the number is x. The problem states the square root of the number, this means square root x, is the same as, it means equals, the number, which is x, divided by 40. Again, he asks about for what positive number is the square root of the number the same as the number divided by 40. So the square root of the number equals the number is divided by 40. Now we can by squaring both sides, by squaring both sides, because we have square root, we will get x, because squaring square root x, squaring square root will cancel the square root, equals squaring the right hand side, you will get x squared, squaring 40 you will get 1600ths. The right hand side is a fraction, and you can put the left hand side as a fraction. You can see that one x will cancel another x by dividing both sides by x. And finally you'll get 1 over 1 equals x over 1600ths. Using cross multiplication, 1 times x you will get x equals 1 times 1600ths, you will get 1600ths. So the correct answer will be 1600. This is problem number 15. The answer is 1600, 1600ths. Let's look at problem number 16. Sorry. Problem number 16. As you can see in the problem, we have a figure, and the problem states in the rectangle A, B, D, F, C and E are midpoints. So C is midpoint, E is the midpoint of sides BD. It means C is the midpoint of BD, and E is the midpoint of DF, respectively. What fraction of the area of the rectangle is shaded? So he asks about the shaded area is what fraction of the rectangle? This is the question is. We have rectangle. This is the rectangle. A, B, D, F, and C is a midpoint, and E is a midpoint, C is a midpoint of BD, and E is a midpoint of DF, and this is the shaded area. The question is, The shaded area is what fraction of rectangle ABDF. To solve this kind of problems, I'm gonna use a strategy called plug-in numbers or PIN, plug-in numbers. What does it mean? It means let BD equals 4, it means BC is 2 and CD is 2. Let DF equals 2, this means DE equals 1 and EF equals 1. Now he asks about the shaded area over area of rectangle ABDF. Now you can see that the area of rectangle ABDF is 4 multiplied 2 equals 8. And now to find the shaded area, you can say that it is the area of all the rectangle minus 2 small triangles, the white triangles. Okay, now the total area or the area of rectangle ABDF is 8 and the rectangle is the same 8 minus. You have to find the area of the two triangles. The area of each triangle is half times base times height, because this is a right angle triangle, or half multiplied by product of the two legs. Half multiplied 1 multiplied 2, you will get 1. So the area of this triangle is 1. And now this is 2, this will be 2. The same, you have right angled triangle. Its area half product of legs, it means half multiplied 2 multiplied 2. This equals 2, because half multiplied 2 is 1, multiplied 2 you will get 2. So this area is 2. Now, the sum of the two triangles together, 2 plus 1 equals 3. Two triangles will be 3. Now, 8 minus 3, you will get 5 over 8. So the final answer will be 5 over 8. This is the correct answer. This is the answer of problem number 16. The answer is 5 over 8. Let's go to another example or another problem. Problem number 17. Problem number 17 states that we have a figure. You can see the figure. And the problem states the graph above shows the amount of water remaining in a tank each time a pail, it means one pail, was used to remove X gallons of water. If 5 gallons were in the tank originally, and 2 1/3 gallons remained, after the last pail containing X gallons was removed, what is the value of X? It's a good question. Okay, imagine with me, you have a tank. This is a tank, imagine with me. The tank contains 5 gallons. It's good. And from the figure you can see that 8 pails were used. 8 pails were used because the last dot is at 8, and this is the number of pails. Then we have 8 pails were used, and each pail contains X gallons, and each pail contains X gallons. If one pail contains X gallons and we used 8 pails, how many pails were used? You can say that 8x. So this means that 8x were removed. 8x gallons were removed from the figure. The figure says that 8 pails were used, and each pail contains X gallons. So the amount removed is 8x. Okay. If the amount removed is 8x, 8x is taken from 5 gallons. So the remaining will be 5 minus 8x. This is remained. This is remained in the tank. And he said in the problem, he said that 2 1/3 gallons remained. This means this value or this quantity equals 2 1/3. Now let's solve this equation. The equation says 5 minus 8x equals 2 1/3. You can change the mixed number into fractions. 3 times 2, 6, plus 1, 7 over 3. This will be 7 over 3. Good. Now you can multiply all sides by 3 to get rid of the fraction. Multiply by 3. 5 multiplied 3, 15, minus 8x multiplied 3, 24x. And this multiplied 3, 3's cancel each other, the rest will be 7. Now, undo what has been done to the term containing the variable. It means minus 15 and minus 15. You will get minus 24x equals 7 minus 15. You will get minus 8. Divide both sides by -1. You can get 24x equals 8. Divide both sides by 24. You will get 24 by 24. 24 cancels each other. X equals over 8, 1. Over 8, well, you will get 3. So the final answer will be 1/3. So the value of x will be 1/3. 1/3. This is problem number 17. Okay. Let's look at problem number 18. Problem number 18 states that if 0 less than or equal x less than or equal y, or in other words, we can say that y is greater than or equal x, greater than or equal 0. And x plus y all squared minus quantity x minus y all squared greater than or equal 25. What is the least possible value of y? Okay. What this problem states, x less than or equal y greater than or equal 0, and x plus y quantity square minus x minus y quantity square greater than or equal 25. Good. What he is asking about, he's asking about least value of y. So he's asking about y. So we have to make all the inequality, we have to put only the variable y. We have to get rid of the variable x. And from this inequality, y always greater than x. But y can equal x. This means the least value of y is x. So y equals x. Because y always greater than x. But y also could be equal x. So the least value of y when y equals x. So you can change this inequality by replacing x by y. This means y plus y all squared minus y minus y all squared greater than or equal 25. Y minus y is 0 squared. This term will be equal to 0. The rest will be 2y all squared greater than or equal 25. This means 4y squared greater than or equal 25. Dividing both sides by 4, y squared greater than or equal 25 over 4. By taking square root of both sides, you will get y greater than or equal 5 over 2. And y is always greater than 5 over 2. This means the least value when y equals 5 over 2. So the answer of question number 18 is 5 over 2. I hope that you understand these problems, and thank you, and see you in the next video. Bye.